Okay, I am Paula J. Welcome to my presentation. A couple of words about myself and what we're going to be talking about. Yes, I see some of the known faces. Welcome back. Absolutely lovely to see you again. And welcome if you are new on my session. They are always very intense, so be prepared for the 45 minutes of a very technical ride about 10 fatal signs. So as you see, I'm the CEO of Secure, and I'm also doing the cybersecurity consulting for customers all around the world. And this is pretty much my job, and it has always been. And if it's about this presentation, what we're going to be talking about, it's pretty much everything that is happening in the infrastructure that could indicate that you've been hacked. And that's not a very positive session, though you've got many different types of subjects that are within the forensics. But what we try to do, and I'm always saying in the name of my team, because I'm not by myself, Secure, it's actually a almost 40 people company in 4 locations, also in US. We've been looking at different types of infrastructure, and we decided to pick whatever is the most interesting out there for you. Now, it's not my first time on Microsoft Ignite, so I've been playing around and speaking at the various types of conferences, also things like Black Hat, etc. And we're together with my Secure team. We really love to share different types of tools and slides and notes, etc. So this is pretty much something that you can expect at the end of this presentation. Everything that I'm going to be mentioning today, you got this, and you will be able to download that later on from our blog. So stay tuned till the end. We're going to share with you the link. Before we start with the whole presentation, I would like to share with you a little bit of a story. So I was actually scheduled to do the pen test at the customer side, one of the biggest banks in Africa. So it's like morning, 9 o'clock. I'm coming over there, just opening my laptop, and I'm so excited. So it's like another fun day of work. So I start my activities. And at 10 o'clock, I had a meeting scheduled with a security team of that bank. So they were supposed to come and tell me a little bit more details about the infrastructure. Yeah? So what kind of components are there, and so something that could maybe help me. Not necessarily, but this is the meeting that usually happens at the beginning of the pen test. So it's like 10 o'clock, and there's literally nobody coming. So, okay, I'm going to give them a little bit of a late window over there, and it's like 10:15, nobody's coming. So I'm calling the guys, and I'm like, okay, where are you? And they're, yeah, no worries, we're coming, Paula, we're coming, we just need to do a couple of things before we go to the meeting, we're coming. I'm like, okay, fine. So basically, lunchtime, I'm calling them again. And they're like, oh, no, we are picking this guy on the way, so no worries, we are coming. I'm like, okay, fine, so I'm waiting for you. And the day actually just finished, so I went back to my hotel. At 8 p.m., there's this security manager that comes over, and he's apologizing. He's like, oh, sorry, Paula. Basically, we just had so many things to do, so let's meet up at 8 o'clock, 8 a.m. tomorrow sharp, so that we're going to meet up, and basically, we're going to give you all the details about our infrastructure. We're going to help you, etc. I'm like, fine, finally some positive energy. So I'm there, sharp 8 o'clock at that bank in the meeting room, waiting for the guys. Nobody there. That's a great thing. And it's like whole security team that's supposed to come to that meeting, by the way. Yeah? So it's quite an important meeting. So it's like, okay, I'm waiting, I'm having fun. Don't get me wrong, I have something to do. So 2:30 p.m., the door is opening. And this is the group of the guys coming. They're so happy, and they're like, oh, apologies. I'm like, okay, right in time. Let's start a meeting, yeah? So my first question to these guys was, okay, guys, so have you ever been hacked? And they're like, nope, we don't think so. I'm like, yes, you have. Yes, you have. You've been hacked yesterday, basically when I was having fun waiting for you at the meeting, yes? So I will... So I'm already a domain admin, having access to your files, knowing a lot about your infrastructure. I don't need you, yes? We don't need this meeting for real. And basically, this was a whole security team, as I mentioned, and they were supposed to, by the way, monitor that infrastructure. And they were picking some other guys on the meetings. Crazy. So what's the moral? Don't let me in an infrastructure. Come on, yeah. I'm a very positive person. So the moral out of the story is that if you're late, the bad things may happen, and they actually happened. So basically, it's exactly like this with the fatal signs. Sometimes it's too late, yes, but at least it's very important to know what happened, and this is pretty much what's going to be the part of our presentation. So in general, when we are thinking about the fatal signs, And basically, we're going to be getting into lots of demonstrations. So stay tuned and be ready for the ride. Are you ready? Awesome, awesome. So what I would like to show you is a pretty bad scenario of a certain type of a user. And let's use this kind of identity over here. As you can get, it's a pretty evil user. So what we're going to do, this is a privileged access workstation. Yeah? So in general, everything that's supposed to be done over here pretty much has been done. But that particular workstation, and we can do a bunch of checks at the very beginning, is not having access to the internet. So this is the case. It is actually domain isolated, so there are many types of tires that we have in this particular configuration, and this workstation is only accessing a DNS server. Now, on this workstation, there is also, by the way, a blocker turned on so that I'm not allowed to run different types of code, and I would like to show you this in a moment, so we're going to get there. So this is a user. Now, what do we need to actually see over here? So who am I/all, that Cruella, these are the privileges that are particular for the user, and this is pretty much, or these are pretty much the group memberships, and she's not a member of the administrators. So what we will need to do over here, and what Cruella wants to do, because she's a very, very evil user, she would like to download different types of files that she could execute later. So let's have a look of how we are able to do that DNS exfiltration of our networks, where we are actually implementing a domain isolation. Don't get me wrong, we're going to be doing bad things today, yes? I mean, I'm not working for Microsoft, so... but we're going to end up positively, so that's going to be the schedule. So let's get into, at that certain point, our E drive. So we've got a folder over here, Ignite 2018, and we can find out that this particular folder is empty. And what we're going to do, well, first of all, we need to download a file from the internet by using only a DNS queries. So how do we do that? We're going to use, for that reason, a very evil tool, which is called NSLOOKUP. And the reason why, by the way, is just I want to show you that even if the machine is protected, there are different types of built-in system tools that can do damage, yes? And this is pretty much the lesson learned out of that presentation from now on. So we're going to specify the type of the record, and that record is going to be fs0 g secure.pl. And we're going to stream that thing into the, let me do it, into the fs.txt. So we're going to be pulling out these records from the internet, and I have that particular example chunked in 3 parts. So fs0, 1, and 2. So what we're going to do, we've got this fs file, so let's do Notepad. And let's fire up this guy. And unfortunately, I need to do it manually because NSLOOKUP is maybe not the best tool to download files. But here we can see that we have nothing but TXT content that is actually in base 64. So it would be great to find out what that actually is. So let me just put that in one line. And I'm going to copy the content of this, so Control-A, Control-C, and we're going to fire it up in the PowerShell. So what happened right now is that we were able to download, and you can check it out, it's a public DNS. Download the file, which is the fs.txt at the end. And right now we're going to do PowerShell, encoded command, and we're going to run that part. You're probably wondering what that is, but that is actually downloading us from the internet different types of other files that we can use for the attack. Yes? Why am I using PowerShell? Because PowerShell could have been blocked. Because NSLOOKUP is just a waste of time, but you can see, I hope, that we could actually spend hours on that demonstration to download different types of files. So I have this file over here, df1, and if we do PowerShell again, we are able to fire it up. First of all, let me fire it up, and then we're going to be digging into more details. So this is the dfps1. And as you see, what this file will do, it will indicate downloading files, more files from the internet. And this is a good opportunity because it's going to take a moment to have a look at what this script actually does. So this script has been downloaded in the E drive, so let's dig in over there. So Ignite, here we go. There's already master script, by the way, being downloaded, etc. So things are coming, yeah? Now, what is in the script is that we are, simply speaking, doing of what we said. We are downloading from the DNS using the TXT resource records different types of files. And which files we are downloading? I am actually, for the purpose of this demonstration, downloading these 2. But normally, I will download these 2. These 2 I have already on my disk. It's just going to take a moment, yeah? So this is how you can do it. So get file from DNS is our function pretty much in this particular exfiltration script. We can find out, of course, what's the status, and as you see, these chunks are coming. Now, the funny part is that you might be wondering, why so slow? Well, it depends on the DNS configuration. Yes? Some of the DNS servers, and you know that, might have a limitation on amount of different types of requests you can have in time from the certain location, etc. So that at the end, this is how we're able to block that kind of a download types in our infrastructure. So we are good to go. And what we have over here, it's this master script that we're going to be playing with. And we've got a whatever logo, yeah? So this is some kind of a picture that just to show you that we have a consistent files. So what we're going to do next, I have these files already prepared. So this is my backup, so that technically we don't need to spend that time on downloading those files. But you can see that we can do it. So I'm just going to technically put them in. And we've got right now next focus, which we're going to be playing pretty much with the master script, but this one in a second. When we are thinking about all these anomalies, this is already something wrong that happened, how you are able to discover this fatal sign. So what has been wrong out there? First of all, there is a network traffic anomaly. We've got different types of DNS queries. There's a lot of them. And then basically, we can have performance issues on the DNS server because for real, who is actually doing a work for us, it's a DNS server, not the client itself, because it's the name of the DNS that is actually downloading that. Yeah? Now, another part is an unusual process communicating over the network, which in this case has been allowed, and that was a PowerShell. PowerShell was actually allowed to download different types of files over here, and this is something that we should always take into consideration while securing our infrastructure. Which files are those? Yeah? Could it be PowerShell? Could it be NSLookup? What is it? So eventually, when we are thinking about the whole situation that we have in this infrastructure, we've got a master script. So let me switch back to the machine. And this is actually where the fun starts. So let me technically put that master script in here, in the PowerShell, and we're going to be digging into this part. So as you remember, Cruella is just a regular user. So let's try out how our privileged access workstation works. Test network connection. This is a little bit more advanced than the regular DNS, so that's why it fails. We can do get child item sheriff share. So this is basically the situation where the Cruella is trying to get access to someone's files, someone's share. And just to show you that she will not be able to do that. But of course, we're going to work on a situation when she would be. Okay? Now, app blocker is turned on. Oh, that's great. Yes, so let's find out if we indeed cannot run the application. And we are running the application from the Ignite 2018 folder, test app blocker, and it says this program is blocked by the group policy. For more information, blah, blah, blah. Okay, guys, you wouldn't be here, I wouldn't be here if this was all that beautiful. So I think it's time to do something malicious about it and really put myself into the Cruella's role. Sounds like an everyday's life. And technically, do something about that situation so that Cruella can't. Now she would be able. So first of all, to be a nice Cruella and to be a nice hacker so that we are able to clean up after ourselves, we're going to do the copy of MSI-exec. MSI-exec is a service that is working on Windows updates. So let's do that. Let's be prepared for that. Now, basically, what we're going to do next, we're going to get into getACL MSI-exec to verify what are the permissions for the regular users over here. So let me just show you this. So that we can see that for the MSI-exec, these particularly users, they only have a read and execute on the particular folder. Now, with a reason, there is actually a PowerShell script that is called invoke 0-day. What do you think it might be? Okay, so here's the thing. There is this 0-day that you all need to know about. And it has been patched, to be fair, 2 weeks ago on the 11th of September. If you installed your update after that, good for you. If you didn't, please do. It has a CVE code 2018-8440, and it's one of the most serious ones within this year that are allowing regular users to act as a local system. It's a pure privilege escalation 0-day. Now let me explain a little bit more about this before we launch it. So this 0-day is relying on the scheduled task because user in general can create in the C Windows tasks a file, the job files, and at the same time, user can create hard links. So what is happening is that task scheduler through the advanced local procedure call, allows to call for the procedure that allows us to change permissions to that job file. And if that job file is indicating through the hard link to the operating system file, in the context of the local system, we are able to change these permissions. So technically, you are able to change any type of file in operating system you want to as a regular user. So let's have a look if we can do it. So get ACL, etc. And right now, we launched the 0-day. So you can see over here that users are still read and execute, but authenticated users, let's find out, let me launch this one first. Yep, so let me do it. Let me find out. Okay, this one needs to wait for the moment. Okay, and then we're going to do get ACLs for the authenticated users. And as you see over here, we are able to have authenticated users allow full control. Yeah, so this is quite painful. I know it's not a waterfall because we can only see that authenticated users have a full control. Nothing is falling here. It's just that we have a full access right now. Yeah. So what we're going to do, we're going to copy our disable AppLocker SVC, our executable, as an MSI exec. So let's do that. And the reason why we're going to do this is because we want to modify AppLocker a little bit. We don't want to disable it. We are vicious, don't forget. So if we're going to disable AppLocker, you're going to notice. What is better to do is to actually introduce a couple of AppLocker rules so that who monitors really if there are like additional rules out there in the AppLocker policy, right? So we're going to allow ourselves to run a little bit more executables. And now what we're going to do, we're going to start that service. So this is how Windows Update service starts, periodically. So when there's a Windows update, a user can start it, and that's the most amazing thing over here, so that later we are actually, as a user, launching that service. And that particular service, by the way, has been written in a very vicious way as well, because it's a little bit like this customer. Yeah? So it's going to talk to the service control manager. I'm starting, and service control manager is going to be like, are you sure? I was like, yeah, I'm starting. But in the background, we're going to be actually executing a bad code that will, A, allow us the persistency. Second, it will actually add, as we mentioned, additional couple of AppLocker rules. So we've got this service. Let's start it. And then we can verify if the AppLocker is off. Yeah? So let's let it run for the moment, and then we're ready to move forward. Yeah? So the service is right now, this is, by the way, the cheating mechanism, because the service control manager is like waiting for that service to actually talk to him, but for real, the service is actually doing something in the background. Start process, test AppLocker. We couldn't do it before. Let's find out what's the situation here. Let me see what we will need to do. Let me start the service once again. So let's find out. Silently continue. And let's see if we can actually move forward. If not, of course, then we're going to figure something else. But this is really something that we will need to get to. OK, so for some reason, that didn't work out. Let me verify that 0-day once again. So that's going to be the situation. OK. And this one basically has been, we've got over here the authenticated users full control. We copied an item. It's already out there. So let's do it again, just to be sure. And silently continue. MSI server, let's move forward. It's a 0-day, so hopefully everything's going to be working here. Let's see. And let's find out if we can move forward. OK. And then start process, test AppLocker.exe, and it's still blocked. Oh, that's interesting. OK. So let's find out what we can do further, yes? OK, so this is quite interesting that our 0-day didn't work out. Let's see. Let me verify that situation. OK. I got a backup here, so basically we're going to move forward to that case. Yep, here we go. OK, let's just start one more time. Maybe it's like it's an AppLocker, so maybe it didn't do it yet. Oh, that's interesting. OK. It looks like it didn't get it for some reason. So I don't know why. Yeah. So basically, in our case, we're gonna let me just show you this on this backup machine over here. Yeah. So we've got that environment over here. So we've got a test AppLocker, and let's verify if we can start it. So this is the same situation over here. And basically, as you see, we're able to start it. Yes. I just need to connect to the remote environment. My team, by the way, is over there doing the same type of activities that I do, so we are correlating the whole operation. So right now, application is not blocked. We are good to go. So this is the moment where we can technically perform a little bit of a cleanup. So let's do that. And later on, what is interesting, and let's summarize what kind of different types of fatal activities we've got. Yes, so we've got unexpected service behavior. So services are starting, stopping at the same time. So this is an unusual activity because these services shouldn't be started by the certain type of users, etc. We've got unusual prefetch content. So prefetch is pretty much the history of what we can do within the operating system, and we can compare MSI files to verify of what has been actually happening. So one of the situations, let me take this out, and we've got different types of system files with different hashes on the computers. Because what we did over here, we have replaced at a certain moment the MSI exec, and this is something that technically allowed us to move forward. And in general, if we do compare MSI exec with the different types of machines, then basically that could be a situation that could actually, well, release as information that something was wrong out there. Okay, so long story short, what is actually next is we're going to be playing with the user's next activities, and we should have at that certain moment a console running a system. But before we get there, let me of course explain the whole situation. So we have already disabled AppLocker. Now, question is, how can we get a console with the system privileges? So that's going to be the situation, because what we did, by running that service, assured ourselves a persistency. And this is actually a persistency through one of the schedulers in the operating system. And we're going to do new item ignite get console. And that get console is like a trigger file for us to actually use this particular vulnerability. So let's move on. And basically, we created over here a file. Let's find out get date, what we got. And pretty much in approximately 7 seconds, if that zero-day vulnerability works, we should be able to move forward, and at that certain stage, we should get, most probably, the system console. And here we go. So if we do who am I, you can see that we are anti-authority system, yes? And from the Cruella, being a regular user, we managed to actually become a local system. How cool is that? So, long story short, this is pretty much the situation that we should all think about. What can we do from here? Yes, so we can, for example, perform the pass the hash attack. We can steal the hashes. We can steal credentials. But if the privileged workstation, privileged access management workstation, the credential guard is running, at that point we will not be able to do much. But we can always verify who is actually logged on in this box. So if we go to the task manager, and we can always do that as a user. In the users, we can see that there is indeed Sheriff session disconnected. And Sheriff, it's a regular user. He's one of the administrators of some kind of servers in our infrastructure. On that workstation, he's not privileged. And our job would be actually to take over this guy's token. And the question is, how are we going to do that? So for that, we will actually use an interesting tool. It's called CQ Impersonate. But before we do that, let's get into a little bit of a summary at that moment. What are the fatal signs? So change of a group memberships. If you were a part of the local system, then basically at that moment, we could actually add ourselves to the group. So this would be one of the activities. One of the other things would be we could grab a privilege, yes? We will not be able to do that because it's actually quite tough if it's about well, discovery. So in general, we're going to be hiding ourselves by impersonating into someone's session. But it could be also an indicator that something happened in our infrastructure. So let's dig in and let's have a look of how we are actually able to perform that particular activity. So let me move back to the machine. Here we go. And at that certain level, let's get into our drive, which we have an E drive, and we've got an Ignite 2019, and we're going to be using the CQ Impersonate. And CQ Impersonate is one of our new tools, by the way, so we are happy to share that. And at that certain moment, we're going to do -u, and we're going to specify secure sheriff. And then we're going to specify -c cmd to start that particular console as sheriff. So let's see if that works. So perfect. We've got a console running as sheriff without the need of giving a password. This is, by the way, a quick message for someone who is running the remote desktop server and allowing users to be local administrators, which is a terribly bad situation, but then everybody literally can be anybody. Yeah? So nice case. By the way, not recognized by antivirus. Okay, so what we're going to do next? The next situation is that at that certain moment, we're going to be actually fetching more information as a sheriff, because it will be great to verify if we've got access to the certain type of a share. This is one of the things. And if sheriff being a person that is actually administering at that certain moment different servers, we can verify what is interesting in the sheriff's user's profile. So let's do that first. And let's do dir. And over here, we've got an SSH folder. Did you know, by the way, guys, that in Windows 7 you have a native support for SSH in general? So this is actually pretty cool. And we're going to leverage that. So let's have a look. Yeah. So let's go into the SSH folder. And let's do dir. And over here, we've got the public key. We don't have a private key because it is actually integrated with the data protection API. It means that we will need to get access to the keys a little bit differently, which we're going to do. But here, what we can do is a type, known hosts. Oh, there's a small typo in type. So let's do it, type, known hosts. And over here, we've got information where this particular user is actually connecting. And this is a 10.10.10.1. So we're going to be leveraging this one. But at that moment, let's find out if Cruella, that we have console of somewhere here, is actually the one having access to that particular server as well. So we're going to do SSH. So this is basically Cruella's console, just to confirm, as you see, SSH. And we're going to be technically just putting this particular IP address. And here, just say yes. Fantastic. We've got the password that we need to provide. Well, Cruella doesn't know the password. Sheriff does. So how can we actually steal these particular keys from Sheriff? And this is basically what we're going to be doing over here. So here we go. So what we're going to do first, SSH, add, and then we're going to list the identities that Cruella might have. And there's literally no identities. So let's try to steal that identity from the Sheriff's console. Yeah? So how are we going to do that? First of all, what we will need to do is to try to export the Sheriff's keys, SSH keys, that are through data protection API. And we can do that by leveraging our tool. So let me show you. That is actually using over here data protection API. So this is a CQ OpenSSH. Let's just get there. OpenSSH, agent decryptor. And it's quite a long name for the tool. And over here, we will try to export the Sheriff's data protection API key. So we're going to do O output, and we're going to do file export sheriff.xml. Fine. And then it says requested registry access is not allowed. Why not? Because OpenSSH, or in general SSH in Windows, works in a way that every single user has the possibility to communicate with the service that is running as a local system, and that service can fetch the key of the user. But in this particular case, we're always allowed to go to the registry, so we can do that on that machine because we managed to use this vulnerability, and effectively, we are able to change that setting in the registry. So let's do that, regedit, and this one is in users. And at that moment, we will need to fetch the SID of the sheriff. So if we do whoami/o, that should all come out. So we've got sheriff over here. And this is a 4104. So let's just use this one. And over here, we go to software. We go to OpenSSH and right-click permissions. And over here, we're going to add. And let's just go crazy because, well, we could specify sheriff, but we could also do authenticated users. Why not? Yeah. Ouch. Okay, so we've got authenticated users. Fine. Let's give them full control. We can do it. I mean, it's a situation. So let's go advanced as well, and let's do replace all child object permission. Okay, fine, okay. So now, technically, sheriff, or we being sheriff, should be able to get this particular key. So let's find out. So this is the output, and then basically we are exporting that key, as you see. So we can find out what is this. So we've got a sheriff XML. And here, guys, you will be able to see that this is nothing but the private key that the sheriff is using in order to connect to his server. Fine. So we're going to be leveraging that as Cruella. So let's go to the Cruella's console, and let's find out if we can connect to this particular entry. So we're going to do SSH, and at that certain moment, here we go, we will need to, first of all, well, as you remember, we were not able to connect, right? So this was not working. So at that moment, we will need to import this particular key. So CQ open SSH, and at that particular key, we do import, and we do file import sheriff to import the data protection API key to the registry. Now, if we do the same stuff that we did before, so listing, this is the sheriff's identity imported to Cruella's profile. So this is pretty bad, because Cruella, in the moment, will try to be actually a sheriff. So technically, what we need to do in order to connect, we need to specify the user over here, so sheriff, at 10, etc. And basically, right here, right now, she is actually connecting, who am I, as sheriff, to host name, the other server. Yes? And IP config, just to show you, here we go, this is the IP address. Now, this is a pretty difficult operation. I'm absolutely not bragging out over here, but our team has reverse engineered fully data protection API. So if you have any questions about the crypto platform in Windows, we're absolutely happy to answer those. And we could do it because we were actually acting as sheriff. And this is pretty much something that allowed us to become that particular user over here and be able to connect to the certain type of a server. Okay, great. So long story short, what we will need to verify, and let's go at the beginning of the script over here, that this is basically our script where we are playing with the certain type of a server, and basically their particular sheriff share, we will need to test if we can get access to that particular share. Of course, the name at the certain points will be changed. So it's going to be, in this particular case, SD01, because our environment has changed, so let me technically change it, SD01, and this is basically SDC01, SDC01, and this is a particular share that we're going to be listing over here that we couldn't list here, but we will be, or we should be able to do that from the sheriff's console. Yes? So if we get over here, then basically we can do the PowerShell, and then we can do, let me just type it at that point. It's going to be SDC01, and then we can use the tab to fill it up. And this should be the sheriff share that we have over here. So let me just get into PowerShell. It will be a little bit more convenient to do it. And then we're going to do dir, of course. Yeah. So dir, and then we've got SDC01, and then sheriff share. Let's pull it. I'm just pressing the tab, so we need to wait for that to come out. No, come on. Sheriff share. Let's try. If we can do it, and it says it doesn't, double F doesn't exist. Let me see. Very secret share. This is an environment case. Okay, so let me just do that. Very secret share. Here we go. And sheriff is able to do it, but if we do take that, and just for the reference so that you guys can see of what's going on, then basically we are here still acting as Cruella. So this is basically what you will need to see, that if we do that on the Cruella's level, then basically Cruella doesn't have an access to it. And this is really very much the point of our situation here. Okay, guys, so this is what we've got as a whole environment over here. Now, question is how we are able to discover of what happened. This is the first thing. Second thing, how and what else we are able to do as Cruella to make sure that we are able to hide our files. And one of the things, basically, we will need to run, it's the Windows subsystem for Linux, and this is also quite an interesting situation over here, because this is something new, and basically our job is going to be over here to get access to that particular subsystem to create different types of files, and this is what we're going to do. So we are right now in the Windows subsystem for Linux, and the question is, how does operating system actually discover it? And for that reason, I've got two commands that I'm going to copy into the environment. So let me, simply speaking, and quickly do that. And we will here create the file, and we're going to pretend to be and ransomware. So imagine having ransomware that is running actually from the inside of the Windows subsystem. So that's going to be quite an interesting situation here. And these are the two commands that I'm going to run. First of all, we're going to do echo very secret file, so test file 3. So let's just do that. Here we go. And for some reason, edit and paste. Well, it didn't copy it or something. Let me see. It doesn't look like it actually copied this to the inside of the machine. So in the worst case, and this is an encount session, so in the worst case, I will need to type it or something, but no, let me just do it again. Copy. Apparently, it looks like copy and paste. It's something difficult. Out of this old DP API things that we have is actually quite funny. Paste. No, why it doesn't work? That's strange. Okay. Anyway, let me just get there and actually let me type it. So it's going to be the fastest way, really. Yeah. Okay. So let's find out. So over here, we're going to technically create this. So it's going to be echo, and then we're going to specify whatever test for the secret file, and then we're going to stream it to the test file 3.txt. Yep, perfect. And then we're going to do echo, and then we're going to specify over here our secret, because our job is going to be to actually encrypt that particular file. So it's going to be super secret or something like that. Fantastic. And then we're going to specify a JPG, and we're going to do batch, and we're going to do passphrase, and 0, and symmetric encryption, and test file 3.txt, and we're going to also remove the file. So we are encrypting the file, and then we are removing it. So it's going to be the test file 3.txt. Okay, good. So this should be all fine. Invalid symmetric. What is the problem over here? Okay, the typo, yes. So symmetric. Yeah, double M. Fantastic. So this is basically the file that we have created. We could have a look at how this file looks like in, for example, Nano. Why not? We could do test file 3.txt. Fantastic. And this is pretty much the encrypted file that we are having over here in Linux. Yeah? So in general, we are not able to see much because it has been encrypted inside the Linux. So this is the file that is visible from the file system of Windows, but at the same time, we work on it from the Linux perspective. So we can close this up. End of activity. So basically, what we need to do right now, as Cruella, we have to, from the Ignite folder, delete all the files, so clean up after ourselves, with the shift, so permanently delete, and our job would be to find out more information about these particular files. Yeah? So let's get into the administrator over here. So I'm going to log off as this girl, and let's find out how this looks like from the forensic perspective. Yeah? So let's talk about the symptoms that we have out there. So we're going to sign her out, and then we are logging on as an administrator, and let's have a little bit of forensics out there. So we're going to do sign out anyway. Okay. And let's get into encount session as well. So view, encount session. And then we're going to sign in here as an administrator as well. So let's do secure. Again, administrator. And let's do password. Or let's do the admin first. Here we go. We've got an admin. Here we go. And then password. And here we go. Perfect. So we are logging on as this guy. And this guy, why like that? Why the whole operation? Because this guy actually noticed that there has been unusual activity on our SSH server. Sheriff, normally, it's not logging on like that. He was maybe on a vacation or something. And this is something that caught the attention of the administrator. And our job would be to find out actually what's going on over here. Yeah? So we're going to go into our analysis. So we've got over here our files. And what we're going to do first, and this is pretty much what you guys would do, we're going to get into autoruns. So let me just get first to tools. And within the sysinternals, we're going to have a look at what runs in the infrastructure. Yeah? So this is one of the first things that we would normally do in this situation. So we can see that, and we can, well, pretty much cut off the Microsoft Corporation part. So we're going to do it in a moment once it's finished. But we can see over here that even though we browse through all these entries, there isn't anything like hilariously suspicious. Yeah? So this is quite interesting situation over here. And we can check out how it looks for the WMI, etc. But there's like nothing. What is quite funny, because if we do run that with the administrative token, it's going to show us more, even though it is still the same token. So it's actually a case of without runs here. So just be careful about this. Yeah? And if we go down over here, let's find out, there's actually something that is like WMI database entries. But we can see it's disabled. So is it good or bad? It's kind of bad, yes? But anyway, let's have a look at that later. In the meantime, what I would like to show you, so we're going to leave it on the side for the moment, is that if we do have sysmon running, what we will be able to do is to look through sysmon in patterns. Our team has written a script that is called CQ Kawaii that is actually discovering different types of cool activities that you can perform by using the operating system files. Let me show you exactly what do we mean by that. For example, this is my live machine right now, and I'm having cert-util. Can you download files with cert-util? It's one of the examples, yes. And there are so many other options that we have right now. So cert-util URL cache, split, and we are downloading right now 7-zip. So let's have a look. Yes, so this is a live demonstration out there, yeah? And after a moment, 7-zip is going to be downloaded. So do you allow cert-util in your infrastructure? I bet yes. Is it that we have to block it? No, we have to control it with what kind of commands it executes. And that is exactly what I have for you in this particular script. So within the CQ Kawaii, we decided to keep it positive. We've got different types of patterns for the different types of operating system built-in files that we can technically run at that moment, yes? So let's see what we can do. So I'm going to run this right now. And we've got an information that the running script has been disabled. It's not a problem for us right now because we are doing the analysis as administrator. So we're going to do set execution policy unrestricted. And we can do it also for all of us. Yes, so yes to all. Bring it on. We have it. Access to the registry key. Let me just see why like that. So I think it will be a matter of running this with the administrative token again. So let's just do that. OK, run as administrator. Here we go. OK, and then we're going to set up the PowerShell execution policy. We can also do that with the Kawaii script, so it will be a little bit more clean at that moment. So let me repeat this operation at that situation. Here we go. Oh, Kawaii edit. Oh, no, OK. For some reason, it doesn't read it. Let me just do it. Files, CQ Kawaii, we got it. And then we're going to do, at that moment, set execution policy unrestricted and for everybody. OK, fine. Let's do it. So over here, let's enlarge it a little bit, and let's start running the script. We're going to be searching for these different types of patterns. Yeah? So let's do it. And at that moment, when it says testing, testing, it's great. But when it's kind of like interrupting the testing activity, then it means that it found something. Yeah? So we're going to have a look at that. So there was like a PowerShell. There was like MSI, exec. So we can see and get into more information, more into details about what's going on in this system. There is also, by the way, quite interesting information about CSC running. And we can see that it is actually matching pretty much the time that we have right now. So we've got a csc.exe, and we are over here all the time compiling the files. So we can have a look at CSC itself. So let's see, because it's actually quite an interesting situation. CSC, here we go. And let me just do the format list over here. Format list, and then format list. And then basically we're going to run these two to verify what is out there being compiled. And that gives us more details, more information about different files that were out there in the operating system being compiled, including cmd.exe, being a parent process. So if we get into more details, like, for example, in this case, get sysmon CQ details, and we're going to specify the path, Windows System32, and then cmd.exe, once again, cmd.exe, enter. Then this guy will show us a little bit more information about certain processes out there, including which processes this guy was actually a parent of, or eventually the opposite. So parent process of CMD was actually strcons. And when you see strcons in your infrastructure, that's a big deal. Because this particular type of a file, it is actually an active script event consumer that allows us to compile the code from the inside of WMI. This is, by the way, something that is used for mining the Bitcoins. And it's actually a pretty popular and serious case that we have right now in our environment, or hopefully not, but this is a sign of something bad happening. Now, whenever we get into more details, what I would like to show you as well is how that bash that we were running over here has been discovered. So in general here, we will need to specify the full path. So let's do that, and let's just search for the whole path. C, Windows, and then we're going to do system. I see the typo, so let's just correct it. Here we go, system32, and then we've got our bash.exe, and basically we're going to remove this parameter over here, and F8. And here we are able to see that we can only see that this process has been executing. So let's do format list and then F8 again. And we can only see that, and we don't see really any type of parameters of the bash. So what is the conclusion is that if you really are into writing ransomware, and hopefully not, that could be a good way of hiding things. So if you can see that, then basically it's a nice way to check, but it's kind of hard at that moment to investigate what was actually happening in the bash, in the Windows subsystem for Linux. Now, the very last thing to show you is actually related with getting into, particularly in this particular machine, getting into different types of files that were deleted out there. So we're going to get into that. So at that moment, from the administrator's level, we're going to get into the command prompt. And let me just, this is an admin, so let me just do that. Let me just, once again, it's command prompt. Come on, come on, come on. OK, let's start that with the administrative token. Run as administrator, fantastic. And what I would like to show you at that level is the way of how we're able to undelete different types of files, so that if the files were deleted, how we are actually able to find them. And on the E drive, in the Ignite folder, basically here, we've got a new tool. It's called CQ undelete. And CQ undelete, oh, this was deleted, of course, so how could we be doing this? So not really that place, not really that place. Let's go to the C drive. And then we're going to get into files. Fantastic, and the CQ undelete is over there. So CQ kawaii, CQ undelete, undelete, here we go. Yep, and this is a tool that allows us to search for and through MFT on the drives and actually recover the files. So let's have a look of what we have on the E drive and if we are actually allowed to run these files or eventually extract these files. So we're going to do -L for listing, -V for volume, and we're going to put the E drive for that. And as you see, there's like plenty of things. Yeah? So this is pretty much what Cruella has been deleting. And one of the interesting things, so there's like lots of different types of tools that we are able to recover. Yeah? But one of the interesting files are the ones that we've been working on over here. So we've got a CQ undelete, CQ system escalator. Let's have a look at this guy. Yeah? So CQ system escalator, enter. And this is something that we actually use within this particular vulnerability. So the recovery, in general, just for the example, is going to look like this. So we've got CQ undelete with the volume. And in this particular case, instead of L, we're going to do U for the undelete. And we're going to specify file. And that file over here is going to be this one, CQ system escalator, out. And basically, we're going to name it .exe, enter. And of course, it's a bad idea to run it, yes, as we know. But at that certain moment, let's do it for the purpose of that particular demonstration. And we've got that particular file over here. So name it. OK, why not? Sounds like someone's name. Anyway, let's run it. And after a moment, what you guys can see is actually a console running with a system privileges without being asked for anything. And this is one of our best escalator tools that allows you, without saying a word, to actually become a local system in the certain type of an operating system. Yeah? So this is the whole final situation out there. So summarizing what we did, we touched the watchdog files. So basically, we technically play with the different types of files in the operating system that when someone plays with those, then you should be informed. Usually a good situation when you've got a ransomware and ransomware is touching those files, then you are able to be informed that someone was playing with those files, so that could be one of the fatal signs. We've played with strcons, where we were able to dig into a WMI, and we were able to, at the end, escalate and run the different types of scripts from the inside of WMI. We discovered patterns in Sysmon. So this is one of the good things over here, because some of the operating system files can technically be used for the malicious behaviors. And at the end, we managed to recover a suspicious deleted files. So these are the 10 fatal signs that we have played with. And at the end, quite an interesting scenario executed in this particular environment. At the end of the presentation, what is important to mention is that all these different types of files, all these different activities, they could be at the end prevented if we had a good implementation of AppLocker and the device guard. So this is pretty much the situation that we have. Usually, we've never seen a good implementation of the AppLocker and device guard in the infrastructure, but it can be done very well. So this is a first conclusion at the end. And at the very end, I would like to sum up this session with something that basically, my friend Ken, by the way, showed me this video. There is this guy, Bueller, do you know? Some of you know, yes? So there's this kind of guy, yeah? And it's a kind of an old movie, by the way. I saw it quite recently. And he said one interesting thing, and that is that life moves pretty fast. You know the rest? And if you don't stop and look around once in a while, you can miss it. And this is exactly how it is with our fatal signs. So sometimes when they are difficult, we can also miss it. And it's important to know good techniques to be able to find those particular fatal signs. So hopefully, guys, you like the session. Please evaluate it, don't forget. Please don't forget to be, thank you. So get the quiz. This is a new quiz that is prepared for you. No registration required to have fun in cybersecurity. At the end, don't forget to find the session summary, slides, and tools in our blog. If you're interested in increasing your skills and advanced Windows, have a look at this. We only run it once a year, so you might be interested. And at the end, at the very end, you can meet me in the Beyond Trust booth just right after the session if you will have any questions. Thank you so much.